So I wanted to make a dummy load for testing this power supply from PDP 1104, and I've got another one from an 1134, so it'd be nice to have a dummy load for testing those two. And I've got several other PDP computers, and although I haven't investigated how compatible the connections on these pins are, it'd be nice if I could make something that I could use for those as well. And in testing this, I used a bunch of resistors like this for 3 of the supplies, but for the main plus 5 volt supply I used a whole bunch of halogen bulbs like this. Well, I used 8 of those, and they're great for dissipating large amounts of power, but they're no good because of their positive temperature coefficient. They're no good for connecting to an active load like a regulator. They interact with each other and cause a lot of oscillations. So I wanted to do the plus 5 volts as well using only resistors. Now that's all going to get pretty hot, so I want to stick it in oil. And the way I'm going to do it could be a general technique. You may find it interesting for making any sort of a dummy load. Not necessarily specifically for something like this, although that's what this project's going to be. So I'll show you how I did it. So here are my materials. I'm going to reuse the same wiring loom and reuse these resistors, but I'll also need a whole lot more, and I just happen to have a bag of 5 watt 6.2 ohm resistors. There's the circuit board that'll go on, and there's my overlay, which I'm going to transfer using an iron. They're going to go into this tube, which will be capped by sockets like that, filled with mineral oil or baby oil. It's very cheap stuff, and I'm surprised. I wouldn't have thought you'd get much oil out of a baby, but it's still cheap, so must be a lot of it. And a top cap and a label to go in there, and the terminals will be up here, and the wiring loom will come out the back on the side. So I suppose first of all I'll make the circuit board. There it is after I've drilled 1mm holes everywhere. Now 1mm is fine for these 5 ohm resistors, 5 watt resistors rather, and it should be the same for the 10 watts. But many of them I'm going to be sticking 3 of these together down one hole. This is for the 5 volt side of things. I'm going to stack them together, and I want all 3 wires to go through the hole, so many of those holes will have to be taken out to about 2mm, maybe even 2.5, to allow those wires through, and several others have to be enlarged as well. A few of these didn't etch so well, but all those isolated ones doesn't matter, because I'm going to drill them out completely anyway. They're going to be oil transfer holes. So, more drilling. So 2mm was fine for getting 3 of those leads through. Some of us had to be made, some of these holes are for thick wires, so they're 3mm holes, and all the oil transfer holes are 5mm. So I think that's the end of the drilling. I can start mounting components. Partway through construction, I'm separating the 3 layers of resistors by a piece of PCB. So PCB resistor, press it all down, fold the wires over on the other side, then solder them on this side, then remove the PCBs, and I'll snip these down when I'm finished. And do the inner rows first, before you do the outer rows, otherwise they're hard to get at. I discovered the hard way. So that's all the resistors for that side. Only one screw up. Didn't pay attention to which way around. No. Oh yeah, it's backwards. And I've cleaned up this side a bit. I could snip them right down to nothing. I mean, they don't have to come through this side at all, but a little bit of extra support, I suppose. And I'm going to space the resistors on this side up with bits of PCB anyway, so they'll be clearing that. I don't think it'll be a problem. Okay, to this side. There was 2 that I forgot about, so yeah, I was thinking there was 10 blocks, but there's 12. Now they're in, and there's the resistors on the other side. So it's a bit lopsided, but that's what the oil cooling's for. And it should fit snugly inside here. Now that's got to be sealed, of course, so it can't leak any oil. And at the other end, I've got to drill a set of holes for these wires from the cable to go through. I think I'll do one for each of those and one for those guys, so 5 holes. And I'll go through this and through this, but then I'll gouge out the holes there so that there's just a cutaway and the wires can go through there, maybe seal them up with silicone. So I drilled holes through from here through that for those 5 lots of wires, and then snipped out the pieces with holes there and ground down that, so that now there's a nice slot for that to go into. Now I'm going to pull these wires out and put the label and holes for the test terminals before I reinsert the wires and connect everything up. So they can come out for now. A bit of sticky stuff. I've glued the label onto the lid there and sprayed it a few times with satin gloss paint, and I've glued the cap onto the bottom of the tube. I've also ground this out a little bit to make it so that there's a bit of leeway in putting that on so that the wires don't get snagged. Next thing is to drill the holes for that and put the terminals in. And there's my banana plugs, sockets put in. Now these are spaced at 19mm, 3/4 of an inch standard spacing, so that double plugs like that can go in, and so I can have ground versus any of the power supplies. The -15 should be blue, so I've got to get a blue one of those. I didn't have one. The +5B should be grey, but I don't think they come in grey, so green has to stand in for that. This extra terminal, short for 32 amps, adds in 2 of these banks of resistors that go to that. The rest are all in parallel and go to this one. So if I put a shorting bar across that, then the last 2 are connected in, and it'll draw nearly 32 amps at 5 volts, and without that shorting bar it'll only be 25 amps, and actually 24. I've got to measure the final resistances, but you know, that's what it's supposed to be, just a bit under 25 and just a bit under 32. So now it looks like just some wiring to do at last. And there she is, finally all wired up. Bit tight up there, but it should be okay. That will fit into here. So the hot side will be towards the front. And that clamps down there. Now, when that's full of oil, it could be easy to knock over. So it could be mounted on a base, but then if you use screws to connect that to the base, you'd have sealing problems. But fortunately, you can use another cap. Just bolt that cap to the base, and then this will just clip into it. Once you've got rid of the air in there that stops it closing fully now, but yeah, when there's a couple of holes there, it'll be fine. And yeah, so that's going to be obviously a lot harder to knock over. So just about done. Now, when this thing's running, you can obviously stick an oscilloscope onto that and look at the ripple, etc., or just a multimeter and measure the voltages. But to know what current it is, you need to know the resistances. So I want to see how closely the resistances actually are to what I've calculated by the resistors that I've put in there. So let's have a look at this on a 6.5 digit meter with using 4-wire measuring technique. Using 4-wire mode and Kelvin clips to eliminate the resistance of the wires in the measurement, I'm going to put this on the 0 volts, and there's 2 of those, so I've got it on one of them and I'm putting pressure against the other pin with my fingers. Now measuring the 2 plus 5 volt pins, 0.21, make sure I'm getting both of them, 0.21, calculated that to be 0.2, so that's pretty close. The plus 15 volts is 15.5, the minus 15 volts is 15.5 as expected because they're identical resistances, and the plus 5B (1.4 ohms). So I think that's exactly what is to be expected. Beautiful. Now I can plug it in, see how hot it gets, and put some oil in too, I guess. A couple of things I should have mentioned before. These large wires there are just in parallel with the PCB traces to take some of the load off them so that you don't get a voltage drop across the length of it. Just thought that was worth doing. Now, and the other thing, I've overlooked the fact that I really should be connecting this to both these power connectors, because although this is rated at 25 amps, that would be assuming roughly equal loads on both those connectors. I doubt that either one of them is supposed to be able to carry 25 amps, and the wires inside are nowhere near as thick as these guys. So yeah, I should splice another connector onto this harness, but I'm not going to do that till I've also looked at my other PDP computers which have different connector arrangements, and once I start splicing onto that, I'll continue on with a couple more for the other PDPs so that I can plug this into any of them, assuming all other things are compatible, like the voltages and current ratings. So it's probably time to plug this in and see what blows up. I'll do it out of here first, see how hot these guys get. With the power control back on the scene because of this strange plug that this power supply needs, we're looking at the 5 volt output. It's plugged into one of the sockets on the PSU, and start winding up some voltage. So 240 volts, 4.89, well, it's probably a bit low, isn't it? And those resistors on the back are predictably starting to warm up. Have a quick look at the other supplies. Minus 15, good. Plus 15, good. And plus 5B. Right. So, yes, a bit of temperature going on there. Probably time to try some oil. This stuff's damn cheap, $2.40, so it's for half a litre, so less than $5 a litre of extract of baby. Now this takes a whole litre, but without the load in it. Let's. Have we got any leaks? Hopefully not. Smells nice. Smells like babies. Okay, I'm going to need more, obviously. All the way down. Yep. Try and get it over the top of the board so that we can get a bit of convection across the top as well, which takes us pretty close to, yeah, only about 5 millimeters below the lip there, so I'm probably going to be causing some spillage if I don't store this thing properly. We'll keep that there so we can watch it boil. Boiling baby oil. And that took nearly the whole 2 litres, whole litre rather. Okay, let's wind up some power again. Bubbles are starting on this side with the 5-volt resistors. 22 on the outside. Leave it run for a few minutes, which is probably long enough to do most testing. You know, this certainly isn't meant to absorb all this heat for continuously, but it enables it to run for a few minutes at least without cooking anything, hopefully. We're starting to get fairly vigorous, the bubbles. In about 4 minutes now. The bubbles coming up off the resistors, they haven't got more and more and more and more vigorous. They're just coming off at a steady stream, haven't really changed much. Now I would like to have made this using aluminium tube like these guys, but I didn't have any that matched any caps I could find, but it could be done, and maybe you have to have a pool of epoxy down the bottom where the tube plugs into the cap, and tuck that in there and then fill that whole bottom area with epoxy, and then you could also strap a heat sink onto that and maybe even put it in a box with a cooling fan, and you don't have to use fixed resistances either, or you could have several standards, like 1, 2, half ohm, quarter ohm, and then have all the wires coming out and a bunch of switches to select which one you want. Different combinations. It could be made more general purpose and a bit more robust temperature wise by using aluminium tube, but I think for testing these power supplies this will be perfectly adequate. 355 watts completely for everything. Well, we've been going for about 6-7 minutes and all's well, which should be long enough to do nearly all testing. Also, I didn't mention the contacts, the pin contacts I've used in these plugs. I could not find anything that definitively said what the rating was for the specific part that I used, but some of the ones that can go into this Maton lock commercial version, some of the pins that can be used with that apparently can go to 20 amps. So I think I got the biggest I could find. I don't think I'm exceeding the contact ratings of the pins, but maybe the wires inside the PSU, because it's all going through one instead of being shared across 2. Anyway, that's been running for coming up to 15 minutes now, and the bubbling in the oil's actually probably gone down a little. Temperatures, let's see, yeah, we can get a 85, 90 in there, 93. The outside is still, well, it's getting very warm, bordering on hot right at the top. So yeah, well, it's hot everywhere actually. And the oil, well, it's hot oil. But 15 minutes is probably a lot longer than you could run with just bare resistors, and that's all I was really trying to achieve here. So I'm pretty happy with that. You could probably go 20 minutes or longer, and if worse came to worse, you could stick this whole damn thing inside a bucket of water. Because it's oil, it's going to float of course, but I was thinking if you could stick a lead weight in there and then plug this into that, it might not try and float, and even if it did, you could put another one with another lead weight on it on the bottom of that. By hook or by crook, you can make this thing stay underwater, and of course inside a bucket it's going to take quite a while to heat up a bucket of water with about 200 watts going into it. That's going to take a while to heat up to destruction, but for short periods up to 15-20 minutes this looks like it's going to be fine. The plastic doesn't seem to have softened, although it's getting almost too hot to touch. It doesn't seem to have softened, so that's a good sign. 16-17 minutes now, so I'll call that good. And something I should have thought of earlier is putting 4 screws there, so that if this thing does fall over, at least the top won't fly off and have oil gushing everywhere. It will still seep out through all these holes for the banana jacks and there as well. I've put a couple of layers of PVC glue on the inside there to try and seal the other side of the holes for the wires, but not really much point in doing that because the holes here are going to let plenty through anyway, but at least it won't be a whoosh, it'll just be a dribble. So to wrap up, this seems to be perfectly adequate for dissipating 150 to 200 watts for about 15 to 20 minutes. Now this stuff here is just 90mm stormwater pipe, which is only 2mm thick. It could be made more stable with sewer pipe, which is about 4mm thick and perhaps even a bit more squat, so it's less likely to fall over. And as I mentioned earlier, you could try and use aluminium pipe as well, but that offers more possibilities for super heat sinking and fan cooling, but these could be stuck in water as well. I think that's just about it for this thing. I'm pretty happy with the result. I hope you found that interesting, enjoyed it. If you did, please give it a thumbs up and subscribe for more of this sort of nonsense. Catch you later.